Okay. So I think last time one of the things we finished off on was really starting to document the use cases. And does your team have anything documented other than, the obvious quantum use cases? Does the team have any documented use cases for what this specification would do?
Yeah, we do have some documentation, basically with I have a couple examples that I think we can go through
Okay.
that shows, yeah, use cases for the different component types that we have, and
Okay.
an actual a bit, yeah, with a larger use
Okay.
case of how you can document an example with an actual application that uses cryptography.
Okay.
So I can share my screen if you want to have a look at that.
Okay.
Right.
Okay. So this is under the examples.
Okay, that's the examples file here.
Yep.
And what we have here is basically, so this is, let's say, the Hello World section here. It shows how we represent the different component types that we have. Algorithms, keys, protocols, libraries, applications. I mean, yeah, library application, that's not something we
Mhm.
added, right? It's already
Yep.
there. Certificates and, yeah, the metadata, that's also not something new, kind of. Right. So on the dependencies, there is a bit larger example, but we can do here.
Mm.
So that's basically you start with a Nginx application, right? Web server. That in this case it uses libSSL to implement that implements TLS, like TLS 1.2, if that's configured, or 1.3, which in turn uses a couple of algorithms, part of that protocol cipher suite. Right. Then there is another, what's also associated with that is a certificate, right, with TLS of like google.com or another website, for example, the signature algorithm used, and the keys associated with that, right, like an RSA key. And you can also specify things like if you have a key, right, server, sensitive material is usually secured in a certain way, right, with an algorithm itself, like AES. It can be there in software, the key. It can be backed by an HSM, preferably, and that's something that can be expressed as well by the secured byte. So that's, I mean, the example here is basically one that you will find right now, right, with the configuration available with standard Nginx or most applications, right? Non-quantum safe algorithms. There is a second example basically that modifies that with some components that are quantum safe, right? And the use case there would be, okay, to say, okay, with the schema that we have, it's possible to express that fact that we have quantum safe algorithms that will be necessary, for example, if you have to follow CNSA 2.0, will be necessary from 2025, for example. So that's something you can actually see when looking at that. So, and again, the example here, that's, for example, if you, I mean, question is how can you build such a C-bomb, right? And here, this example would be possible, for example, if you have a network scanner that detects, right? You can, for example, like passive network monitoring, also active network monitoring to test what cipher suites a certain web server Nginx, right, supports, and then we will find out this information. There are other kinds of scans will produce, let's say, different flavor, right, of the same picture. They could be complementary. So that's an example. So that's how the CBOM would look like, right? So there, the schema here, basically, if you make a JSON file out of it and run it against the schema validator, tested it will pass the the schema validation against 1.5 CBOM, which is an extension of CycloneDX 1.5. So right, so that the component here is Nginx, right? So we have here a couple of components. First component is the Nginx application itself, right? A certain version. Second component here is libSSL from OpenSSL. And then the next component is the protocol. So here we have asset type protocol. That's TLS 1.2. So we also have some guidelines, right, in the documentation on how to create a BOM ref for that case, right? So to have some kind of unique identification for that case. So which would be, okay, it's a crypto asset, the protocol, the name of the protocol, and then the version of the protocol. I think that's something that probably will have to be specified as well, right? How to express that exactly with kind of Perl-like thing. Anyway, so we have here.
Let me just let me think. I think I understand here. I've got like two different scenarios. I maybe have like a library, and I can then obviously describe what ciphers, etc., that library implements. But I can also do that on a service. So if I have a microservice somewhere, I can also, because of your changes to the dependency graph, I can also say that this service depends on but implements this particular set of ciphers, for example. So both of those use cases would be possible, correct?
Yeah, so with service you mean there's components and service, right? So that's what
Right. That
service.
if I wanted to just represent a service, I could say that this service actually implements these cipher suites.
Yeah. So the dependencies is it's not part of components, right? So you can have dependencies from services to components, right?
Right.
So yes, you could also
Okay.
start with a service, right? So you could have, I don't know, like a service that uses Nginx, right? And then you would have that this dependency graph attached to it.
Right.
So yeah, that was also a reason why we added that to these dependencies.
How would you
And
like say for example you have this Nginx, or you don't even actually you don't even know it is Nginx, right? You just know it's a service. Maybe I'm fetching stock quotes from like Yahoo stocks or something, and I have no idea what they run. All I do know is that the service that my application depends on, that service supports TLS 1.3 only, and maybe a really strict set of ECC ciphers. So how this example right here, you have Nginx uses libSSL, implements TLS 1.2. How would you do it from the service, where you have a service, you don't necessarily have visibility into what it's running, you just know what it provides?
yeah, I mean, yeah, it always depends, right, what information you can gather, right? I mean, if you can gather from the service that this service is actually using Nginx, right, then this would apply to here. You
But
could
how would you go from the service to implements without that uses step? Would that be a valid use case?
Yeah, I mean, you could directly have a service that uses TLS 1.2, right? So, or a service that implements TLS 1.2, right? So that's something you could
Uses,
also
okay.
do.
So uses would be the appropriate thing, or I'm trying to figure out like which one it would be. Would the service use TLS 1.2 or would the service implement TLS 1.2?
Yeah, I think it would be um could be let's say, I mean, what you can observe is probably that it uses it, right? You
Okay.
don't know that it implements it, right? So
Right.
that could be
Yeah, because
done.
in reality, we could be hitting a load balancer, which isn't the actual service itself, right?
Yeah. Then I mean, I think you could have multiple C-bombs generated as well. You observe with a network scan that there is a service that uses TLS 1.2 with this configuration. And then if you are able to scan the I don't know, maybe the Docker container or so where the service
Yeah.
runs in, you could get additional information like, oh, there is
Okay.
another component involved, right? And then to build up then one would be able to build up a more fine-grained
Right.
dependency graph.
Okay. All right. All right. Sorry for, I just wanted to, I was just
Mm,
trying to wrap my brain around everything that you were just showing and how that implements to both, how that would work with both components and services. Okay.
yeah. I think there is also another scenario where I mean, if where you would have, let's say, more a software scan, source code scan.
Hmm. Right.
There you would find, I mean, everyone can scan Nginx source code, right? And then um, build additional dependencies, right? Then you would say, aha, okay, Nginx uses libSSL, which uses libcrypto, which implements any algorithm that libcrypto implements, right?
Right. Right.
Weak ones and strong ones, and that might be useful information as well, right? For
Yep.
some policy.
Absolutely.
So this is
Okay.
just one view, right? And there can be multiple views on the same thing with
Mm.
different um, granularity.
Okay.
And right. So at the end, I think if the use case is, let's say, more on the policy side, right? You want to detect if this scenario is now, let's say, if you have policy that says quantum safe, is this quantum safe, right? Then the reasoning could be automatic, actually, right? Could go through the schema here and see if there is any algorithm here, right? I mean, we have this asset type algorithm, and we have this property here, NIST quantum security level, which
Right.
need to be more than 0 to be quantum safe, right? That can
Right.
be something where one can reason about them.
The um the CNSA version 2. I have a question on that for you. I was going through there and it appears, you got the SHA, I think they recommend SHA 384 or something and higher. But I noticed that SHA-3, that the entire suite of SHA-3 was not supported, which I found interesting. Was that, it seemed like all the SHA-2 stuff supported, but not SHA-3. Did you find, am I looking at it wrong, or?
It might be right. Let me. Right, yeah, they say, I mean, if I read the document here, they say use SHA-384 or SHA-512. Yeah.
Yeah.
Yeah. Yeah, that, I mean, just looking at the document, it seems accurate, yeah.
Okay. Yeah, I find it interesting that SHA-3 wasn't supported for some reason.
Okay, there is a, yeah, there is an FAQ I see here. Okay, they mention here SHA-3, right? Because there is many quantum safe algorithms internally use SHA-3. That's the
Right.
for internal hashing and for generating random seeds. So yeah, they have no concerns about that.
Okay.
But does not anticipate approving SHA-3 algorithms for general purpose use at this time. Okay.
I see. Okay. Okay. All right. I completely missed those two sentences. Okay.
Yeah. I think that's something, I mean, if you look at the CBOM, that could be checked as well, because if you look at the CBOM, for example, by the Open Quantum Safe libOQS, so that's this quantum safe library, it says if the algorithms internally use SHA-3, it expresses that with a dependency.
Right.
So that's something you can find there, and apparently that's okay, right? According to CNSA 2.0. But for other uses, they don't approve it.
Right. Okay. Yeah, the general use, right?
Mm.
Right. Okay. That makes a lot of sense. I know that you said you only had 20 minutes today, so
Yeah.
I'll be cognizant of your time. What I think I'll do is
drop in 1 or 2 minutes, yeah, fortunately.
okay. What I think I'll do is I'm going to start a Google Doc, and I'm not going to replicate everything in your examples, but that's pointless. But what I'll do is I'll start a Google Doc and kind of write down like 5 use cases, maybe a few maybe like a sentence or two, kind of explaining each one, and we can when we meet back up like next week, we'll just go through that just to make sure that we're able to achieve those use cases. And of course, if anyone else wants to contribute use cases, more than merrier. We'll just make sure that what we currently have can achieve those use cases, and yeah.
Yep. Sounds good. Yeah.
So we're actually making some changes in 1.6 that are unrelated to this, that we might also benefit from. So I can next time I'll share that with you as well, because I think it might be applicable, especially for reusability.
Yeah. Sounds good. Yeah. I will post a link as well of the examples to the Slack channel.
Yeah, perfect.
It'll be interesting for.
And as soon as I get that Google Doc created and populated, I'll go ahead and share that in the Slack channel as well. Well, I won't keep you. Have a great rest of your day, Basil. and always a pleasure talking to you, and chat with you next week.
Yeah. Thanks, Steve.
All right.
See you
Cheers.
next week. Bye.